Bismillahirrahmanirrahim. Assalamu alaikum. My name is Munazza Nasir and I am from Hamza Army Public School and College, Boys. Welcome to Online Support Program 2020, Week 2 for Class 8th. My subject is Chemistry and today we are going to talk about the topics from Week 2. This week's topics involve some very important terminologies in chemistry and it includes relative atomic mass and atomic mass unit, molecular mass and formula mass, empirical formula and molecular formula, and chemical species. And the chemical species that we are going to talk about today include ions, molecular ions, and free radicals. And by the end of today's lecture, students will be able to learn about all of the above definitions as well as their examples. From the previous knowledge, students have an idea about what is an atom and what are the subatomic particles that are present in an atom. Subatomic particles are the particles that an atom is made up of, and they are electrons, protons, and neutrons. They have also learned in the previous lectures about the following terms as element and compound, and they also have an idea about ions and how exactly are they formed. The first terminology that I am going to talk about is relative atomic mass, and it is the mass of an atom of an element relative to the mass of C12, that is isotope of carbon with mass number 12. Some examples of relative atomic mass are given in this table. Hydrogen has relative atomic mass of 1.008 AMU. Nitrogen has relative atomic mass of 14.0067 AMU, whereas oxygen has relative atomic mass of 15.9994 AMU. Now this AMU is the unit used to describe relative atomic mass. It is known as atomic mass unit, and it can be defined as mass of an atom exactly equal to 1/12 the mass of C12 atom. We know that mass of one C12 atom is 12 AMU. So 1 AMU is the mass of one C12 atom divided by 12. AMU is the unit that is used to describe relative atomic mass of different elements, and relative atomic mass is the older terminology for the modern day terminology known as atomic mass or mass number. Next terminology that I am going to discuss is molecular mass. And molecular mass is defined as the sum of atomic masses of all the atoms in a molecule. For example, water is a molecule made up of 2 hydrogen atoms and 1 oxygen atom. So molecular mass of water can be calculated by multiplying the atomic mass of hydrogen with 2 and multiplying the atomic mass of oxygen with 1 and adding them both together. Hydrogen has atomic mass of 1.008 AMU and oxygen has atomic mass of 16 AMU. So after doing the calculation as above, we get the answer of 18.016 AMU, which is the molecular mass of water. The next terminology that I am going to talk about is formula mass, and it is the sum of atomic masses of all the atoms in a formula unit. Formula mass is written for ionic compounds specifically. For example, table salt or sodium chloride is an ionic compound made up of sodium ion and chloride ions, and its formula states that it has one atom of sodium and one atom of chlorine in it. So its formula mass can be calculated by adding the atomic mass of sodium and chlorine together, which gives us an answer of 58.5 AMU. Our next terminology is molecular formula, and it is the chemical formula that gives the actual whole number ratio of atoms of each element. For example, hydrogen peroxide is a molecule that contains 2 hydrogen atoms and 2 oxygen atoms in it. So H2O2 is the molecular formula for hydrogen peroxide, And similarly, glucose is a molecule that contains 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. So C6H12O6 is the molecular formula for glucose. And our next terminology is empirical formula. It is a type of chemical formula that gives us the simplest whole number ratio of atoms of each element. Sometimes, for some molecules, ratio of atoms of elements that are present in it can be simplified. For example, hydrogen peroxide H2O2. It contains 2 hydrogen and 2 oxygen atoms in it. The ratio of hydrogen and oxygen here is 2:2, which can be simplified to 1:1. And this leads to a formula of HO, in which there is 1 hydrogen and 1 oxygen atom. So H2O2 is the molecular formula which can be simplified to HO. So HO is the empirical formula of hydrogen peroxide. Similarly, in glucose, we saw that it contains 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. So this ratio 6:12:6 can be simplified to 1:2:1, which leads to a formula of CH2O. So CH2O is a formula that is a simplified version of C6H12O6. That is why it is the empirical formula of glucose. Our next topic is chemical species, and the first chemical species is an ion. Ion is a charged species that is formed from a neutral atom when it loses or gains an electron, and that is why ion can have a positive or a negative charge. Some common examples of ion include sodium ion, which is represented by Na+1, chloride ion, which is represented by Cl with a charge of -1, oxide ion O-2, and magnesium ion Mg+2. There are 2 major types of ions, cation and anion. A cation is formed when a neutral atom loses an electron, so it has a positive charge on it, and anion is formed when an atom gains an electron, so anion has a negative charge over it. Generally, cation formation is seen by elements which are metals, and anion formation is usually seen in elements which are non-metallic in nature. The next chemical species is molecular ion. A molecular ion is any ion that is formed when a molecule loses or gains electrons, and it can also be positively or negatively charged. Some common examples of molecular ion include oxygen O2 with a positive charge, CH4+, this is another molecular ion, OH-, this is a molecular ion with a negative charge, and CO3 with a charge of -2. Basically, molecular ion is any ion with a positive or a negative charge that is made up of 2 or more than 2 atoms. And the last chemical species is a free radical. A free radical is an atom that has an unpaired electron and it does not have a charge, and for that reason free radicals are electrically neutral species and they contain odd number of electrons compared to ions which contain even number of electrons. In this picture we can see that what a free radical typically looks like. This picture represents an atom which has 5 electrons in its outer orbit, and we can see 4 of them are in the form of a pair, whereas 1 is unpaired. So this is how a free radical typically looks like. Some examples of free radical include chlorine free radical Cl dot with over it, and bromine free radical Br with a dot over it. Now we have reached the end of our lecture for this week, and now I am going to summarize what we have learned. We learned that relative atomic mass is the atomic mass of an element as compared to carbon-12, that AMU is the unit to describe relative atomic mass, that sum of atomic masses of all atoms in a molecule is molecular mass, whereas sum of atomic masses of all atoms in a formula unit is a formula mass. We learned that molecular formula gives the actual whole number ratio, whereas empirical formula gives the simplest whole number ratio of atoms. And from chemical species, we learned that ion has a positive or a negative charge due to loss or gain of electrons. Molecular ions contains 2 or more than 2 atoms in it, whereas a free radical does not have a charge. That's the end of today's lecture. Thank you and Allah Hafiz.